Hi guys, this is Ajaz. Today we learn about SimScape. So first thing is, what is the SimScape? So SimScape is the toolboxes for solving or simulating the physical systems. So what is the special in physical systems? If you take any domains, mechanical, electrical, thermal, or any domain, in physical domains we have various components have various physical various physical quantities have various units. If we are dealing with mechanical, it will have torque, velocity, acceleration, weight, dimensions. If you are dealing with electrical, it will have voltage, current resistance. If you are dealing with thermal, it will have thermal conductivity, reflectivity, emissivity. So all these physical quantities have different units. So while solving while solving or simulating this system, one thing is this unit should be common. 5 meter is not equal to 5 centimeter. It should be in all units must be in some particular common unit. And this various physical domains have various different cross and through variables, and this various physical domains have various governing equation explaining the physical systems. For mechanical systems, various governing equations will be there. In this governing equation, basic variables will be velocities, deflections, velocity, accelerations, and force. If it is electrical, then the basic variables will be current, voltage. If it is thermal, then will be thermal conduction, and the temperature difference. So these basic variables will create the differential equation that will define that physical systems. But defining the physical equation for a particular system is not so easy. And while solving also, we need to convert all variables in the same unit system. So writing the physical equation for every physical system is not so easy. So what MATLAB did, it made it easy for us to solve this physical systems. They have created this SimScape. In this SimScape, they have created libraries for various physical systems. They have already created blocks with differential equations describing that physical system. So it will be easy for us to use these blocks and create and simulate the physical system. So that is the basic goal of SimScape. In SimScape, if you have basic SimScape license, you will get only this foundation library. These are the additional toolboxes: Sim, driveline, Sim electronics, Sim hydraulics, Sim mechanics. For that, you need to have the additional license. If you have only foundation library, you will get this libraries or toolboxes. So now when you are working in SimScape, you need to add some additional blocks into your model. That blocks are, first you need to have solver configuration in your model. You must have solver configuration when you are working in SimScape. Otherwise, you want your model, you won't be able to solve your or simulate your model. Why you need this solver configuration? So okay, thing is, in various component, you are adding the various values of the various variables. Suppose in damping coefficient, you are adding Newton per meter per second. Here, and in spring rate, here adding in Newton per meter. Suppose here you are adding centimeter per second. So in this case, both the units are different. 5 centimeter is not equal to 5 meter per second. You can't take directly the values. So first thing what you need to do is you need to make this unit common. So for that what you need is this solver configuration. What the solver configuration will basically do, it will bring all these quantities of different unit in a same unit. So in simple, it will make it simple unitless thing, because when it is all things are in the same common unit, you no need to worry about the unit, no need to consider the unit. After that you can solve it with a simple Simulink solver. So that is the use of this solver configuration additional block. So after solving this model with some common units, if you want your result in different unit, in that case this Simulink physical to Simulink converter will help you. See here, my output signal unit is centimeter. I am taking displacement as the output. So my result is starting from 100. Suppose now I want the result in meter. Now I am changing this into meter. Okay. Now again I am simulating it. Now see, my result is starting from 1. So that's how this physical to Simulink block will help. One more block is there, Simulink to physical converter. If you are connecting any signal to your physical system, so you can't directly connect a Simulink signal. In physical system, every signal has some unit. So for giving unit to that system, first you need to connect that physical system to this Simulink to physical converter block. Here you can select your required unit, and then you can connect it to your physical component or physical system. Okay, one more thing is in SimScape various physical domains are there. So for various physical domains, this connection lines also have different colors. In mechanical, it has a green color. If we check with some other, suppose we are checking with magnetic foundation library, magnetic. So in magnetic, it is having red color. So one more thing is, can we directly connect this component from different domains? We will try. See, we are not able to connect it because I am trying to connect this electrical element. Suppose I am taking this electrical capacitor, I am trying to connect it with my mechanical system. Am I able to connect? No. So what is the reason why I am not able to connect it? Because the variables, the cross and through variables. The cross and through variables for different domains are different. First we are working in mechanical. So for mechanical, the through variable is force if it is translation. If it is rotational, then it is torque. And across variables are displacement or velocity. While in electrical, it is through variable is current and across variable is voltage. The current is due to voltage difference. The force is due to velocity difference. You can say that. The heat flow Q is due to temperature difference. So this is the reason why we can't connect directly components from different domains. But we can make a common, we can connect it through proper connection. We can convert this mechanical signal into simple signal with the help of this PH to S converter. Then again we need to convert from PS to S means physical to Simulink converter, and after that the signal will be simple signal. Again we can convert into Simulink to physical converter. After that we will apply the unit of electrical systems, and we can connect it to electrical system. So this is the how this SimScape will work. And one important thing in SimScape is this solver configuration. When you click this configuration parameter, you will get this solver configuration pop up. Here you can in Simulink we have two options: fixed variable solvers and variable step solver, fixed step solver and variable step solver. In each we have various options. Some additional options we also have. These additional options will help us help us to make our solution more accurate. And in SimScape, this solver selection is important. Why? Because our physical system, some systems are stiff, some are not stiff, some are continuous, some are non-continuous. So according to the characteristics of system, we need to select the solver. So it will give us proper results. The solver selection process is also not so simple. So I will make one more video explaining the solver selection process. Okay, so this is from today's video. If you want to learn more about the difference between Simulink and SimScape, I have already made a video. Link is given in below description. Check that video. After that, your difference between Simulink and SimScape will be more clear to you. And still, if you have any doubts, any queries, put the comment. And in next videos, I will explain the solver selection process. And after that, in some videos, we'll also solve some Simulink SimScape examples of different domains. So we will get to know how to use the SimScape. Okay, thank you guys.